Hi, and welcome to this tutorial video on the engineering application of Cramer's rule. To begin with, let me explain what Cramer's rule is all about. Cramer's rule uses multiple linear equations with several unknown values and expresses them in a matrix format. Then using this format and matrix-based multiplication and division, the determinant of the matrix is used to solve for the missing values. For example, x and y.
Named after the late Gabriel Cramer, Cramer's rule was published in 1750. Many scientific and engineering applications which occur in daily life are ultimately modeled around the systems of linear algebraic equations. Linear algebra is also known as the study of vectors and scalars, which play a very strong part of engineering mathematics across all faculties. Cramer's rule utilizes both the matrix and determinant to solve unknown equations. One of the key facilities that is applied in is the Faculty of Electrical Engineering, specifically in node analysis.
In electric circuit analysis, a node is a point where elements or branches connect. For nodal analysis, the current around the node is examined and will also be equal to 0. It can either be solved through the use of Kirchhoff's current law, or sometimes it is solved through the use of equations. Now, the best way to solve these equations and solve nodal analysis is through the use of Cramer's rule. Here is an example of how Cramer's rule works. Step 1. Here are the linear equations that will be used as an example of Cramer's rule. We have the x column, the y constant, or the y column and the constant. Now, converting these into a matrix. Step 3 begins with assigning names, the coefficient matrix, the x matrix, and the y matrix, using the coefficients. Step 4 is to find the determinant using the following formula. Step 5, solve for x using the formula dx over d. And step 6, solve for y, dy over d. Using x and y now will give you your x and y coordinates.
Apply this method to nodal analysis in electrical circuits. The thick blue lines seen above here are the nodes of the circuit. Using Kirchhoff's current law, we can deduce that the currents coming into and out of node 1 equal to 0, and the currents coming into and out of node 2 are equal to 0 as well. These equations could be further simplified to give this at node 1 and this at node 2. In matrix form, it is as above. The determinant of the above matrix can then be found to be 11, and then the Cramer's rule is used to find V1 to give 37.82 and V2 to give 32.73.
Thank you for watching our video.
Perfection, it's your world, it's that human being.